Okay, this is Math 2. We're doing 107 to 113. And I think I'm skipping 108 because that's just way too easy. So 107 is the absolute value function f of x equal absolute value of x is sometimes written as a piecewise defined function. Sketch the graph of f of x equals x squared. I'm sorry, absolute value of x. So there's the actual graph. The question is, write a set of equations to represent f of x as a piecewise defined function. So be sure to include the domain for each piece. Now, I'm just going to straight up write this out because it helps sometimes if you go backwards to really understand what's going on with the absolute value function. So the first thing that I'm going to do is I'm going to actually give you the f of x, the piecewise function that represents the absolute value function. And I need another color so I can do this darker. This looks like f of x equals, we're going to say x when x is going to be more than, do we want to do an equal? Actually, it doesn't matter. Greater than or equal to 0, and negative x when x is going to be less than 0. Okay, there's the function. There's a piecewise function. Now, I'm going to make sure it actually makes sense to you. So, here's what we're going to do. First thing is we're going to graph this. So, I'm going to do the lines in purple because this should help you out. Okay, x is, there's a 1 over here. It's like 1 over 1 plus 0. So it starts at 0, and then it goes up 1 over 1, up 1 over 1, up 1 over 1, and then it goes in the other way. So it really just is your function f of x equals x. There's your parent function. And that's the first one. And then the second one is negative x. So that means I start at 0, go down 1 over 1, down 1 over 1, down 1 over 1, because it's like negative 1 over 1 plus 0. So down 1 over 1, and it really just looks like they're crossing each other at 0, which really they do. They are, in fact, perpendicular to each other, since you do have opposite and reciprocal slopes. Okay, now, this obviously doesn't look like the equation f of x equals absolute value of x. So how in the world do you go from what we have here to the absolute value of x function? So the restriction on the domain, as far as I know, belongs where x is equal to 0. So I'm going to do the orange line, or the dashed line, at x equals 0. Hopefully you can actually see that through. Okay, so here's what it says. It says you want to keep the function, the first function on top. You want to keep the x, which is technically this one. This is the whole line. You want to keep this line right here when x is greater than or equal to 0. So that means when we have the boundary of the left side, the left side or the right side of the dotted line, everything greater than or equal to 0 is going to be on the right-hand side. So I no longer need this little part down here. We only want to keep this part of the function over here when x is greater than or equal to 0. So I'm going to erase this part. Okay, so I only want to keep less, that means it's going to be a solid dot, and I'm only going to keep this portion right there. That's that part, the first part. All right. Now, the next one says, okay, well, if you're keeping this, you can't have this and that at the same time. That's really what it is. You can't, if you're going to erase it from this side, okay, that's great. But now when you look on the right side, you have two of them. That's not a function. It has to pass the vertical line test. You only have one input for x versus for one output of y. So if you're going to keep this blue one, that means this part gets erased. Or if you like to think of it, you want to keep the function negative 1 over x, this one, only when x is going to be less than 0, which is technically on the left-hand side. So if you're going to keep this one here, open circle, And you can't really see open circle because the open circle is on top of the closed circle. If you're going to keep this side, then you really don't need this part right here. There you go. Done. So this is the piecewise function for the absolute value of x. Now, aren't you glad we only use absolute value of x? Because it really works out. You want you want x, when you want it to be positive, when x is greater than or equal to 0, you want it to stay positive. But in case I ever give you an x that's negative, I want to turn it positive. So I want to make sure it's always going to be in the positives up here. Then you would multiply by -1, which is what we did there, and then for x less than 0. Okay, so that's the piecewise function. 109. For the quadratic function f of x, 2x plus 1, or 2 times x plus 1 squared minus 5, what's the minimum, or does it have a minimum, or does it have a maximum point? So the question is it opening up, or is it opening down? That's the question. If you say that it opens up, then obviously you're going to have a minimum point. So what is it? Then you'd have a minimum. If you say that it opens down, then you're going to end up with a maximum. In either case, the minimum and the maximum points, whatever you decide, which way it opens, is going to be your vertex. So when it asks you for the value of the function at the minimum or the maximum, it's really asking you, what's the vertex? That's really wants to know. So you have to decide based on this function, does it open up or does it open down? If it opens up, it has a minimum. What is the vertex? What's the minimum? What's the max? What's the vertex? Okay, that was 109. That was fast. Sorry. Okay, 110. It's kind of long, so that's why I needed to breeze through this. What is the area of the shaded region for the regular pentagon at the right of each side, if it has a side length of 10? So realistically, we could do this the hard way, we could do this the easier way, depends on what you really want to do. My advice is to find the area of one triangle, which is what you should know how to do. And then since there are 5 of these triangles in here, then find the area of one triangle and just multiply by 3 and you should be good to go. So I'm going to give you a setup for this. You really should know how to do this by now on your own. If this whole triangle here has a base of 10, okay, there it is. And the way that you find this angle is 5 minus 2 times 180, and that gives you 540. 540, there's 5 equal angles in there since it's regular. Divided by 540 divided by 5 is 108. 108 split into 2 equal pieces is 54 a piece. So if you're looking at just one triangle, I guess you could say this triangle is really this one right here. This is 54, that's 36. I don't know why you would need the 36. I don't know why you need that. Okay. You know the whole base is 10 already, so you're looking for the height of the triangle because you already have the base. You just need to find the height. Base times height divided by 2. That's the area of this triangle. So find the height. You need to use trig, right? You either have sine, cosine, or tangent. This is your hypotenuse. You don't have any numbers on the hypotenuse. I don't know why you would find the hypotenuse. It's probably not very important, but you could find it if you really wanted it to. This whole base is 10. This is the apothem that comes down from the center to the side. So technically both of these parts are equal. So if you cut 10 in half, you should have 5 and 5. So now you have a triangle. I'm just going to pull this out over here. It has a base of 5. You want to find this. You have 54 degrees. There's your right triangle. So are you going to use sine, cosine, or tangent? Because you have opposite and you have adjacent only. So find the height. And you should get the area of this whole triangle is around 34.41 right there. So I guess your height is going to be around 6.88 or something around there. And then you have, so that's the area of one triangle. And then you have 3 of them that are shaded. So just multiply the area of one triangle by 3, and that should give you the area of the shaded region. Okay, 111 is weird. A particular spinner has only 2 regions, green and purple. So if the spinner is randomly spun twice, the probability of landing on a green twice is 16%. What is the probability of the spinner landing on the purple twice? Okay, so I'm going to draw a circle. Okay. First spin is purple and green. The second spin is still purple and green. Okay, I don't really know. I'm just going to make something up. Okay. There we go. I don't know what that is. It's definitely not 90. But they're both the same. Well, that definitely does not look the same. Actually, you know what? We don't really need a second. Yeah, we don't need that. We could just do one. Okay, I don't know what this is, but it's not 90 because it's definitely not a right angle. You can check. It's not 360. I mean, it's not 120. I don't know what it is. It's just something. But I do know portion of it is going to be green, and a portion of it is going to be purple. So I guess your giveaway is the green is going to be less than the purple. Green, and then portion of it is